Number 10. Przybylski's star. In the constellation of Centaurus, 370 light-years from Earth, a celestial object is quietly rebelling against the entirety of modern chemistry. Its official designation is HD 101065. Astronomers call it by a shorter name, Przybylski's star. This star contains elements that should absolutely never exist in nature. It is a living, breathing paradox, a bucket of cold water dumped over humanity's complacency regarding our understanding of the universe. It all began in 1961, when astronomer Antoni Przybylski analyzed the light spectrum of this star. The returned results sent shockwaves through the scientific community. Instead of the familiar spectral lines of hydrogen, helium, or iron, the atmosphere of HD 101065 was densely packed with highly bizarre rare earth elements like holmium and ytterbium. But that wasn't the most terrifying part. What turned this star into a physical ghost was the unmistakable presence of einsteinium and californium. Here is the core problem. Einsteinium has a half-life of only 20 days. Californium has a half-life of 2.6 years. On the cosmic timeline, these lifespans are mere blinks of an eye. They decay into lighter elements at an unimaginable speed. On Earth, humans can only synthesize them in state-of-the-art nuclear laboratories or through destructive thermonuclear explosions. They cannot endure in nature. Yet, Przybylski's star has been burning for billions of years. For elements with lifespans measured in weeks to appear prominently in its spectrum, the only logical answer is they are being continuously replenished. Right now, inside that star, a nuclear factory is working non-stop to pump these super heavy elements to the surface. No known model of stellar evolution can explain this. Astrophysicists have exhausted themselves searching for a reason. Initially, they assumed the star had accreted material from a nearby supernova, but telescopes swept the surrounding space and found absolutely no supernova remnants, no debris clouds, and no companion star that could have exploded. Next, they suspected instrumental errors or laboratory misidentifications. Yet, for over 6 decades, countless telescopes around the world have repeated the measurements. The spectral lines remain. The truth is undeniable. Theoretically, nuclear fusion in the core of a normal star stops at iron. Beyond iron, the fusion process consumes energy rather than releasing it. A star with the mass of HD 101065 simply lacks the temperature and pressure to forge elements heavier than iron, let alone the super-heavy actinide elements at the very bottom of the periodic table. But Przybylski's star does not care about our limits. It continues to shine, continues to illegally manufacture forbidden elements. Its chemical composition is completely impossible. The periodic table has rewritten itself at these coordinates. Either our entire understanding of nuclear physics is fundamentally flawed, or a bizarre mechanism, a completely unknown energy source, is operating inside that massive reactor. That star is a lonely factory in the void, and humanity is completely blind to what powers it. Number 9. Beta Lyrae. Modern physics models of binary star evolution dictate a brutal and absolute law. When two massive stars orbit too close, tidal forces will stretch, distort, and decay their orbits. Friction generates extreme heat, angular momentum transfers, and the orbit collapses. Physics grants them a maximum of 1 million years. After that, they must either merge into a single hypermassive entity or rip each other apart in a catastrophic collision that shakes the fabric of space. This is a hard limit. The universe does not permit prolonged stagnation on the brink of death. Yet, the Beta Lyrae system does not care about this limit at all. Roughly 960 light-years from Earth, in the constellation of Lyrae, two massive stars with a combined mass of 57 solar masses are locked in a deathly embrace. They orbit so close they are touching, sharing an atmosphere, merging their outer skins. This contact binary completes a full orbital period in less than 2 weeks. By all accounts, this configuration should be an instant death sentence on the cosmic timescale. Beta Lyrae should have destroyed itself long ago, long before humans ever evolved to build telescopes to observe it. Yet, it stands there, defying the flow of time. Doppler spectroscopic analysis reveals a terrifying reality. Mass is screaming from the primary star to the secondary star at a staggering velocity of 10,000 kilometers per second. The primary star is so severely distorted, it resembles a mangled giant egg, while the secondary star is completely swallowed, hidden inside a thick and chaotic accretion disk. The system is continuously losing mass, with stellar winds blasting material into the void of space. This frantic mass transfer should be accelerating the orbital decay, forcing the two stellar cores to smash into each other in a cosmic blink of an eye. Yet every computer simulation fails when applied to Beta Lyrae. Contrary to every chaotic scenario mapped out by mathematics, these two stars sit in perfect equilibrium, frozen in an impossible configuration. They are not merging, they are not separating, and they are not evolving any further. For millions of years, the system has remained as stable as a perpetual motion machine, regularly changing its brightness every 12.9 days, like a countdown clock with a jammed hand. Beta Lyrae is not merely an astronomical anomaly. It is a deep fracture in the theory of stellar evolution. It forces physicists into a terrifying dilemma. Either our understanding of orbital dynamics and cosmic tidal forces is fundamentally broken, or we are witnessing a cosmic accident frozen in time, a system trapped at an unstable singularity that resolutely refuses to collapse. The stars burn on, locked together, defying the death knell of the universe. Number 8. Magnetars. The universe is full of extreme objects, but there is a type of dead star that exists on the very fringe of absurdity. They are called magnetars. These are not just ordinary neutron stars. They are entities possessing the strongest magnetic fields known in the entire cosmos, a destructive power so immense that it turns fundamental laws of physics into worthless suggestions. To date, we have identified only about 30 of these objects among the billions of stars in the Milky Way, and each one stands as a direct challenge to humanity's scientific understanding. To grasp the sheer scale of this impossibility, consider Earth's magnetic field. It is powerful enough to move a compass needle and protect our atmosphere, measuring roughly 0.5 Gauss. The magnetic field of a typical neutron star is 1 trillion times stronger than that. But a magnetar? Its magnetic field is another 1,000 times more intense than a normal neutron star's. We are talking about a staggering 10 to the 15th power Gauss, or 100 billion Tesla. This is no longer a mere measurement. It is an impossible state of existence. This extreme magnetic potency leads to terrifying consequences. If a magnetar were to appear at a distance halfway to the moon, its magnetic pull would instantly wipe out all magnetically stored data on Earth, including every credit card and computer hard drive. But that is only the beginning. At that distance, the magnetic field would be strong enough to rip the electrons right out of the atoms in your body. You would dissolve, not from an explosion or heat, but because the basic chemical bonds holding your body together would simply cease to function. Your atomic structure would be stretched and distorted into long, thin cylinders, completely destroying all biological functions. A magnetar is a destroyer of matter at its most fundamental level. The core paradox that astrophysicists face is this: how can such an object remain stable? Theoretically, such an extreme magnetic force should generate monumental pressure, enough to collapse the star itself. Yet, magnetars endure. They do not just exist, they are violently active. Their surfaces, a hyper-hard crust made of tightly packed iron nuclei, frequently undergo starquakes. When this crust cracks under the colossal pressure of the magnetic field, it releases a catastrophic amount of energy. On December 27, 2004, such a blast from Magnetar SGR 1806-20 was recorded. In just 1/10 of a second, it unleashed more energy than the Sun emits in 150,000 years. This eruption, occurring 50,000 light-years away from Earth, was still powerful enough to saturate satellite detectors and disrupt our planet's ionosphere. If it had occurred within 10 light-years of Earth, it would have triggered a mass extinction event. The existence of magnetars shatters the standard model of stellar evolution. They suggest that either our understanding of ultra-dense matter is fundamentally flawed, or some unknown mechanism is actively working to sustain these impossible magnetic fields. Number 7. Caffau's star. In the constellation of Leo, roughly 4,000 light-years from Earth, sits a star that should never have been allowed to exist. Astronomers call it Caffau's star, officially designated as SDSSJ 102-915+17-2927. This star is a paradox, a severe fracture driven deep into the very foundations of the stellar evolution models we have painstakingly built. It is too primitive, too pure, to the point where its existence directly defies the physical laws of star formation. It all begins with the nature of matter. Following the Big Bang, the universe contained only two primordial elements, hydrogen and helium, along with a trace amount of lithium. No iron, no oxygen, no carbon. Astrophysicists refer to elements heavier than helium as metals. These metals do not spontaneously generate. They are forged exclusively inside the nuclear furnaces of the very first generation of stars, the hypermassive population 3 stars. When these giants died in catastrophic supernova explosions, they scattered metals into space, enriching pristine gas clouds to set the stage for the next generation of stars. Our Sun is rich in metals because it formed much later in cosmic history. But Caffau's star completely upends this order. When astronomer Elisabetta Caffau and her team analyzed its spectrum in 2011 using the Very Large Telescope, VLT, in Chile, they were shocked. This star contains almost no iron. Its iron content is less than 1/10,000,000th that of the Sun. It is a living fossil, a survivor from the dawn of the cosmos, dating back more than 13 billion years. This is where the boundary between science and the impossible collapses. For a pristine cloud of primordial hydrogen and helium gas to collapse into a low-mass star like Caffau's star, roughly 0.8 times the mass of the Sun, celestial mechanics demands a cooling mechanism. Hot gas possesses immense pressure, resisting gravitational collapse. To contract inward and ignite into a star, the gas cloud must radiate heat away into the surrounding environment. The most efficient coolants in the universe are carbon and oxygen. Without these two elements, gas clouds in the early universe would remain scorching hot and diffuse, capable only of forming hypermassive stars hundreds of times the size of the Sun, or collapsing directly into black holes without leaving a trace. Caffau's star has no measurable carbon. Its overall metallicity is far below the absolute theoretical minimum required for a star to form. It is like a massive skyscraper built without a foundation or mortar. The astrophysics community hit a complete dead end. They scrambled to find an escape route through modified mathematical models. Could that primordial gas cloud have cooled through some exotic mechanism involving molecular hydrogen? No. Realistic calculations prove molecular hydrogen is completely inefficient at those temperatures. Could this star have accreted material from a unique type of supernova that released energy but no iron? Supernova simulations reject this strained hypothesis. The naked truth remains. Caffau's star has been burning stably for the last 13 billion years, despite the fact that every human physical equation dictates it should be a non-entity. Its presence is a chilling warning that we are missing a massive piece of the cosmic puzzle. Number 6. Eta Carinae. In the constellation of Carina, roughly 7,500 light-years from Earth, sits an astrophysical monster that refuses to obey any known laws of stellar evolution. This is Eta Carinae, a binary star system whose very existence stands as a defiant provocation to modern physics. It is not just a star. It is a cosmic entity teetering on the absolute edge of catastrophic destruction, an undead core desperately delaying its own inevitable collapse. What makes Eta Carinae truly terrifying is its extreme energy output and incomprehensible destructive potential. The primary star, Eta Carinae A, possesses an initial mass estimated at over 100 times that of the Sun. Consider the Eddington limit, a hard physical threshold where a star's radiation pressure becomes so violently intense that it strips the outer layers and blasts them into space. Eta Carinae does not merely touch this limit, it is constantly dancing above it. This stellar giant burns with a staggering luminosity 5 million times greater than the Sun. In a single fraction of a second, it radiates as much energy as the Sun emits over the course of an entire century. In 1843, Eta Carinae underwent a violent, cataclysmic event known as the Great Eruption. Over a brief period, it rapidly brightened to become the second brightest star in the night sky, despite being thousands of light years away. During this outburst, it violently ejected a colossal mass of material, equivalent to 10 to 40 solar masses, straight into the void, forging the dumbbell-shaped homunculus nebula we observe today. This debris cloud is currently expanding outward at a blistering speed of 650 kilometers per second, a velocity violent enough to instantly rip apart any planetary structure in its path. The core paradox that current stellar evolution models utterly fail to reconcile is how Eta Carinae managed to survive. When a massive supergiant sheds such a monumental fraction of its mass in a single explosive event, physics dictates that the core must immediately collapse into a black hole or obliterate itself in a total supernova detonation. Yet, Eta Carinae survived. It retained its dying core and continues to burn in a highly unstable, volatile state, completely invalidating standard cosmic timelines. The presence of its ultra-hot companion star, Eta Carinae B, creating extreme tidal forces, only injects further chaos into this contact binary configuration. Eta Carinae is a ticking physical time bomb. Astrophysics confirms it will eventually detonate as a hypernova in the immediate cosmic future. The only remaining question is when. It could happen 100,000 years from now, 1,000 years from now, or potentially tomorrow. When that definitive moment arrives, Eta Carinae will unleash a burst of light so blinding it will be visible during broad daylight, burning brighter than the full moon. The resulting surge of cosmic radiation and gamma rays could interact directly with Earth's atmosphere, threatening our ozone layer. Number 5. Sirius B. Sitting right within the observational realm of humanity, a mere 8.6 light-years from Earth, is an entity that silently challenges the most fundamental laws of thermodynamics. This is Sirius B, the companion star to Sirius A, the brightest star in the night sky. By all accounts, it should be a simple subject, a collapsed stellar corpse that strictly follows textbook astronomy. But reality says otherwise. Sirius B is a cosmic ghost that refuses to cool down at the rate required by modern physics. It stands as a blazing paradox right in the backyard of our solar system. In essence, white dwarfs are the remnant cores of stars that have completely run out of fuel. They no longer possess nuclear fusion cycles to generate new energy. They exist solely on the residual heat left behind, continuously radiating it out into the endless void. This cooling process follows strict physical laws. Heat flows from hot to cold, entropy increases, and the temperature drops over a timeline that can be calculated precisely based on the star's mass and composition. Currently, Sirius B boasts a surface temperature of 25,000 Kelvin. This is an extremely intense temperature for a late-stage white dwarf, which typically ranges from only 8,000 to 15,000 Kelvin. When standard stellar evolution models are applied to this specific temperature and mass, scientists calculate that Sirius B has only been cooling for about 100 million years. And this is precisely where the mathematical nightmare begins. Its companion star, Sirius A, has a firmly established age of 250 million years. These two stars were born together from the very same dense molecular cloud. They must be the same age. For Sirius B to exist in its current white dwarf form, its progenitor star must have possessed a massive bulk, estimated at least 5 times the mass of the Sun, to burn through its fuel rapidly, transition into a red giant, and collapse into a white dwarf within 150 million years before beginning to cool. However, if such a massive star had once expanded into a red giant at such close proximity, it would have inevitably engulfed Sirius A, or, at the very least, violently disrupted its orbit. Yet, Sirius A remains completely normal today. Its rotation rate is normal, its chemical composition is stable, and its orbit is perfect. Sirius B acts like a time cheater. It is either too hot, too young, or formed through a cosmic mechanism that lies entirely outside human understanding. Many hypotheses have been proposed to break this deadlock. Some suggested that Sirius B accreted matter from an undetected companion to reheat its surface, but no debris or material streams exist around it. Others assumed that the computational models for degenerate matter are fundamentally flawed, but admitting that would mean the entire dating system for white dwarfs across the universe completely collapses. Number 4. The Methuselah star. In the constellation of Lyrae, 190 light-years from Earth, sits an entity that defies the entirety of modern physics. Its official designation is HD 140283. Astronomers call it by a more chilling name, the Methuselah star. It is older than the universe itself. We have an extremely precise figure for the age of the universe. The Planck telescope scanned the cosmic microwave background radiation, measuring the remnants of the Big Bang, and delivered a definitive answer. The universe is 13.8 billion years old. This is an absolute limit. Nothing can exist before existence itself began. A child cannot be born before its mother. That is fundamental logic. But the Methuselah star does not care about human logic. This bizarre star is a subgiant tearing through the galactic disk at a terrifying speed of 1.3 million kilometers per hour. When scientists analyzed its spectrum, they were horrified to find its composition is almost purely hydrogen and helium. Virtually no iron, no oxygen, no carbon. These heavy elements are forged inside stellar cores and scattered into space only when stars die. Methuselah contains so little iron that it must have formed at the absolute dawn of time, from the primordial gas of the universe. In 2000, calculations of its luminosity and temperature yielded an impossible result. The star was 16 billion years old. Physics collapsed. It was burning 2.2 billion years before the Big Bang occurred. Before time itself even existed, panic consumed the astronomical community. They tried everything to disprove the data. Instrumental error? Calculation flaw? No. In 2013, the Hubble Space Telescope was deployed to scan its position, recalculate distance via parallax, and reanalyze oxygen abundance. The new result came back at 14.46 billion years old. Lower, but still impossible. It is still 660 million years older than the cosmos. The only way scientists can cling to reality is by applying a massive error margin of plus or minus 800 million years. Only by forcing themselves to look at the absolute lowest limit of that uncertainty does the star's age barely overlap with the universe. But that is mere avoidance. The most probable value still dictates that this star is older than the cosmos. Methuselah stands there, solitary and defiant. It presents two terrifying scenarios. Either our understanding of stellar evolution is fundamentally broken, or humanity's calculation of the cosmic age is a joke. The universe is far more ancient and mysterious than we dared to believe. The Methuselah star is a time machine running backward, and we have no idea what is powering it. Number 3. Tabby's star. Roughly 1,470 light-years from Earth, in the constellation of Cygnus, sits a star that is actively shattering the boundaries of modern astronomy. Its official designation is KIC8 462852, but scientists know it by a far more familiar name, Tabby's star. Looking from the outside, this appears to be a completely ordinary F-type main sequence star, slightly larger and hotter than our Sun. According to standard physical laws, the behavior of such a star should be exceptionally stable and predictable. Its luminosity is a fundamental constant, sustained over billions of years until its hydrogen fuel is entirely exhausted. But Tabby's star does not care about the textbooks we have written. It blinks without reason. When a gas giant like Jupiter transits in front of the Sun, it blocks a mere 1% of the star's light. This is a perfect mechanism of celestial mechanics, periodic, predictable, and clean. Yet, data captured by the Kepler Space Telescope revealed that Tabby's star experiences sudden, catastrophic drops in brightness of up to 22%. These dips are not periodic. They follow no mathematical pattern, and they offer no warning. The dimming events occur completely at random, lasting for days or weeks before the star abruptly returns to normal. Even more disturbing, archival photographic plates dating back to the 19th century reveal that the star is undergoing a persistent, long-term decline, losing 1.5% of its overall brightness over the last 100 years. The cosmos is hiding something massive right before our eyes. Astrophysicists immediately scrambled to explain this behavior through natural mechanisms. The first hypothesis proposed a massive swarm of exocomets orbiting the system. If tens of thousands of comets fragmented and crossed the line of sight, they could theoretically produce asymmetric light curves. But the mathematics broke down. To block 22% of an F-type star's light, the sheer volume of required comets would number in the hundreds of thousands, all perfectly aligned in an impossibly narrow window. Furthermore, there is no evidence of a recent planetary collision that could yield such a colossal debris field. The next hypothesis was interstellar dust clouds drifting between Earth and the star. By the laws of thermodynamics, when dust absorbs visible light from a star, it must heat up and re-radiate that energy as infrared light. The most sensitive infrared telescopes were deployed, and the data returned a haunting silence. There was no anomalous infrared excess. A standard dust cloud does not exist there. The star is simply losing its light without leaving a thermal footprint. When every natural explanation collapsed, scientists were forced to confront a forbidden hypothesis: an alien megastructure. In 1960, physicist Freeman Dyson postulated that advanced civilizations would eventually construct vast arrays of solar collectors around their host star to harvest energy, a Dyson sphere. Massive, artificial panels moving in independent orbits would produce the exact chaotic, irregular light curves we observe at Tabby's star. The fact that the dimming is wavelength dependent further supports the idea that the obscuring material is a dense, web-like grid rather than a solid cosmic body. Tabby's star remains out there, thousands of light years away, flickering mysteriously in the deep night. Number 2. The Hypervelocity star. Around 29,000 light years from Earth, a lone star is racing through the void. Its scientific designation is S5-HVS1. The measured speed has reached a record-breaking 1,700 kilometers per second. This number is equivalent to roughly 3.8 million miles per hour. This velocity is fast enough for it to cross a massive nation in less than a minute. Meanwhile, the standard escape velocity of the Milky Way is only about 550 kilometers per second. Any celestial object that exceeds this limit will break the galaxy's gravitational pull and drift into intergalactic space forever. This star is traveling 3 times faster than that threshold. It is a hypervelocity star, a solitary fugitive. Astronomers can rewind the trajectory of S5-HVS1 by precisely measuring its current position and velocity. When reconstructing its past route, all paths lead to a single point, the galactic center, right next to Sagittarius A star, the supermassive black hole located at the heart of the Milky Way. This shocking expulsion occurred roughly 5 million years ago. Theoretically, the mechanism behind this extreme velocity acceleration has already been answered. It is the Hills mechanism, proposed in 1988 by astronomer Jack Hills. The scenario unfolds when a binary star system ventures too close to the supermassive black hole. The black hole's brutal tidal forces tear the binary system into 2 halves. One star is captured and bound into an orbit around the black hole. The remaining star is flung outward at extreme velocity through a gravitational slingshot effect. This mechanism works perfectly in mathematical models and has actually explained most other hypervelocity stars in the universe. But S5-HVS1 completely fails to fit that scenario. Spectroscopic analysis reveals that this is a single A-type main sequence star with a mass roughly 2.35 times that of the Sun. The data leaves no trace of a past companion, nor any debris from a destroyed binary system. It is a single entity and has always been single since its birth. The Hills mechanism strictly requires a binary system to trigger. No law of physics allows a single star to achieve a velocity of 1,700 kilometers per second through a conventional gravitational nudge. The maximum velocity a lone star can receive when interacting with a black hole stops at a threshold of 1,000 kilometers per second. S5-HVS1 has exceeded this theoretical limit by 70%. The question remains, where is its companion? If the binary system was ripped apart, the other star must be orbiting the black hole. Yet, when scouring the central region, telescopes found nothing. There is no captured star, no radioactive remnants. S5-HVS1 was discovered in 2019 by the Southern Stellar Stream Spectroscopic Survey while they were mapping the galaxy. Subsequent measurements confirmed that this velocity is real. Something at the galactic center fired this star away using an invisible weapon with a terrifying power that far exceeds the Hills mechanism. The black hole is the only suspect, but current dynamical models are completely helpless to explain it. S5-HVS1 is like a bullet already fired, racing forward to defy every star evolution model that humanity has painstakingly constructed. Number 1. Zombie stars. In the vastness of the cosmos, there is an immutable law governing stellar death. Massive stars burn through their fuel, their cores collapse, and their outer layers detonate in a catastrophic supernova explosion. What remains can only be an incredibly dense neutron star or a deadly black hole. The star is dead. This is basic stellar evolution. This is pure physics. Yet, the universe always finds loopholes to break the very rules it established. Look at the terrifying reality of the entities astronomers call zombie stars. Burning corpses that flatly refuse total annihilation. Typically, Type 1 A supernovae are absolute thermonuclear explosions. A white dwarf star accumulates too much mass from a companion star until it breaches a critical mass limit. Its core ignites. Carbon and oxygen fuse in an uncontrollable chain reaction. The star detonates. In a standard Type 1 A supernova, destruction is 100%. The star is completely erased from reality. Nothing remains except a cloud of gas and radiation expanding furiously into interstellar space. However, Type 1 AX supernovae choose a completely different script. They explode, yet they survive. The first shockingly confirmed case was SN 2012Z, located in the galaxy NGC1 309, roughly 110 million light-years from Earth. Images captured by the Hubble Space Telescope prior to 2012 clearly show a brilliantly glowing blue star. On January 23, 2012, this star exploded. The supernova flared intensely for months, exhibiting all the hallmarks of a standard light curve, the exact spectral signatures of a total, destructive thermonuclear detonation. But a horrifying plot twist occurred in 2014, when scientists redirected Hubble back to the original location to observe the remnants. They were left speechless. The star was still there. It was dimmer than before, but it was still burning, still fusing hydrogen, still fiercely clinging to life. Mechanically and physically, this is completely impossible. A supernova is an unbinding event that releases energy far exceeding the gravitational binding energy of the star itself. Every constituent atom should have been hurled into deep space at speeds approaching the speed of light. The star should have vanished entirely. Subsequent spectral analyses confirmed that SN 2012Z expelled roughly 30% to 50% of its original mass into space. The colossal, expanding debris cloud surrounding it contains half of the original material, yet the core itself remains completely unscathed. It stands in defiant wholeness, continuing to generate light and heat. Modern physics possesses no theoretical mechanism to account for this. When a white dwarf detonates, the shockwave must propagate through the entire stellar structure. There is no such thing as a partial explosion. There is no such thing as a controlled burn under that immense pressure. A star either survives intact or is utterly destroyed. These zombie stars choose to do both at the same time. Since that groundbreaking discovery in 2012, astronomers have hunted down and identified more than 30 similar Type 1 AX events across the universe. All of them follow a single, bizarre motif: a violent explosion, followed by silent survival. The progenitor stars remain vividly present in archival pre-explosion photographs, and the post-explosion remnants sit proudly shining years later, a direct mockery of current stellar evolution models. The timeline is broken. The law of conservation of energy is challenged. The survival mechanism simply does not exist on the scientists' papers.